To understand the concept of federation, let me make it very clear with looking at an example. Now, why we need to have a concept of Hadoop Federation when it comes to dealing with the data? What is the concept of Hadoop Federation? It clearly says a kind of division in between name node namespace and the block storage. Now, why do we need more than one name node? Because everything was going well in 1x version. When it comes to 2x version, why do we have to have a concept of Hadoop Federation? Now, let us say I have only one single name node in 1x version. This example is pertaining to 1x or Gen 1 of Hadoop. Now, let us say I want to store some data. Let us say I want to store a file, and the file's metadata. Here not I am considering the size of the file, I am considering the size of the metadata. So now what actually makes so important that we have to a little bit careful about the metadata size is, we'll understand that with an example. Now I have a file, and that file's metadata, let us say it's equal to 1 KB. So I have a file whose metadata size is 1 KB. Now let us say if I have 100 files like that, and the size of the metadata would be equal to it's approximately it's 1 KB, it's 100 files, each file again is of 1 KB, so that would be as equal to as 1 GB. It's all simple mathematics. Now if I have, let us say 100,000 files like that. Now if I have 100,000 files and each file's metadata is equal to 1 KB. So in such scenario, the whole size of metadata would reach to 10 GB. So each file's metadata is 1 KB, and like that I have 1 lakh files, 100,000 files. So obviously that would go to 10 GB. Let us say I have something like this. I have the number like this. So obviously with the calculation that we have, that would reach to 60 GB approximately. So this is the size of the metadata. Now this is the size of metadata. Now the reason why we have to consider the size of the metadata is, that's where the concept of Hadoop Federation comes into picture. Now all this metadata would be handled by the name node. So name node also handles certain amount of data in it. So here, as the number of files get increasing, you will also see the size or the size of the metadata or the data that we are trying to store on metadata or a name node is also getting increased. So the more number of small files, you will have more amount of data, metadata has to be stored on metadata. So more number of files, more number of data on name node. So that is directly proportional. So what happens is, if you look at the typical hardware configuration of any typical cluster, we have learned that a name node would have as close as to 64 GB of RAM. It's a kind of a standard cluster hardware, though you may have more RAM depending on your cluster and the data that you are dealing with. But generally speaking, to analyze why we have to have the Hadoop Federation is because here the typical name node configuration would be 1 TB of hard disk and 64 GB of RAM. Now if you look at this, only these many files almost occupied the RAM. That means it already occupied the entire name node space. As we all know, the name node, the metadata would always be stored on the main memory of the name node of that particular machine. So here I already did 60 MB of my main memory. Now if some data also comes in, that's when the scalability of any other data being added onto the cluster would come. So there is always a bottleneck when it comes to metadata if you increase the number of files on a cluster. Now here the statement that we have to remember is Hadoop or HDFS can store any large file data, any large, no matter how big that file is, it can store it on a cluster. But the problem is large number of small files. When it comes to many number of small files, that when the bottleneck of scalability of metadata would occur. That is the reason sometimes, the clusters, the Hadoop clusters in Yahoo and Facebook, that's what they have faced, because a lot of data being dumped onto the clusters of Yahoo and Facebook. So what they have come up with is, they do have a certain problem if you have only one single name node and the rest of all the data nodes. That's when they have come up with is, they are facing a little problem. That's when in 2x version the concept of Hadoop Federation has been introduced, on which what they have decided is to have more than one name node or more than one namespace, or more than one name node on Hadoop 2x version of Hadoop. So in 2x version, now what really happens? As we have been saying, we should be having more than one name node when it comes to Hadoop Federation. But basically what happens? Let us say here you have all the data nodes, or that can be explained something like this. If you have all the data nodes like this, these are all the data nodes you have, and you have a data node 2, data node 1, and to make a little easier, we are saying that is a data node 3. Now this all together we can call it as common storage. Yeah, we can call it as common storage. So on top of which now we can have name node 1, name node 2, and name node 3, and for each name node, as we have learned, we would have a namespace. It's a part of name node. So namespace. So it may go on and on. Now each name node would have some RAM, and each RAM would be pulled from each of these name nodes. Now this is the common storage for the data nodes, but here what happens is, as we are considering more than one name node, each name node would have its own RAM. This also has its own RAM, and name node 3, other machine also has its own RAM. Now each name node's RAM would be pulled and put on a common pool. Let us say this name node has a 200 GB of RAM on it, and this name node has a 200 GB of RAM, and this name node has a 200 GB of RAM. So this is all together combined, and virtually it would be kept on a single pool. Now each name node out of the 600 GB, let us say this name node needs more than 200 GB of namespace or metadata, that would be allocated to this from this common pool. So this would be pool 1, this would be allocated for this name node, and let us say this pool 2 may be of 200 GB or more than that, that would be allocated for this, and this would be pool 3, and this would be allocated for this from this common pool. Now this is a common pool for all the namespaces. Now the point here is, here though we have it depending on the kind of data that we are dealing with, so each name node can have access to more than what it has. Let us say this name node has only 200 GB, but when it comes to connected to a pool of the memory that can use, the boundary can be increased from 200 GB to 300 GB depending on the priority. Let us say this is only for the production. This is only for the production. The full can be extended to 400, and if it is name node 3 deals with testing, then 200 of GB of RAM we allocated this to name node. So from a common pool, what happens is, depending on the availability, depending on the demand, the namespace can have its own namespace from a common pool. That is the advantage of having more than one name node. So what happens? The processing becomes so fast, it becomes very easy for the scalability. That is one of the advantages. And the generic storage, actually this architecture opens a door for new implementations. One of the advantages that we can see from here, this kind of architecture, is the scalability. That means no matter how many number of small files you have on a cluster, yes, now I can have more number of cluster because I do have more namespace or more metadata allocated for each individual name node or namespace. Now the scalability can be high. Now the second thing is generic storage. That means this architecture opens door for so many other new implementations and design simplicity or simple design. Now this is how Hadoop Federation can be explained on a single word. If you ask me what is Hadoop Federation, is having more than one name node or a namespace, which actually helps us for the scalability and for the generic storage and for the simple design. The next concept in Hadoop 2x cluster architecture is high availability. With the name itself, we can understand what is the meaning of high availability. Now we have seen what is Hadoop Federation is. Now we are going to look at what is high availability. The first one was Hadoop Federation, and the second one is high availability. Now I just wanted to add few more points related to Hadoop Federation. Now we have learned the concept of vertical scaling when it comes to storing the data on a single node cluster, or in general file system or in the distributed file system. What happens is, if you wanted to store more data, though you have one processor, you keep on adding the machines to one machine. So you can keep on adding the storage devices. Now let us say I have only one machine. What I'll do is I'll keep on adding the storage devices to this machine. So what happens is, now this process is called as vertical scaling. Now the problem with the vertical scaling is, you'll have only one processor and so many storage devices. That means one processor has to handle so much of data, which is again becomes a bottleneck. You cannot can do that. That's a problem being solved by using something called as horizontal scaling. Again, when it comes to 1x version, what we have trying to do is, we are trying to have a concept of horizontal scaling of the name node. Now this term, please do remember, horizontal scaling of name node. That means it becomes very easy for the scalability. Now the second topic that we are going to discuss is high availability. Now who is going to be available? What is the meaning of high availability? As we all know that in Gen 1 Hadoop or 1x version of Hadoop, we have a name node, and we call this as a master node, and something called as secondary name node, and attached to are all the different data nodes, data node 1, data node 2 and data node 3. Okay, now here if you look at, I'll have communication from data nodes to the name node and name nodes to the data node, but at any point in time I do not have any communication happening between the secondary and the data nodes. This is one point that we have to remember. But overall, if you look at this diagram, we have name node as a single instance, name node we have only single instance or single machine, and secondary also we have single instance or a single machine. Now here, as we have seen, name node is being the master node of the cluster. If you look at 1x version architecture, we only have one name node for the cluster, or 1x version architecture runs on one name node for the cluster. That means there is a huge chance, that if name node gets failed, if name node something happens to the name node, of course we have secondary name node, and there is again a time limitation. Only hourly data would be captured from the name node onto the secondary name node. So that 1 hour data, there is a chance that we may miss that 1 hour data. Or here, if you look at here, name node is being the single point of contact, or we can also say this as single point of failure as well, single point of contact, or this also can be called as single point of failure. There is only one point. Name node is only one node which handles the entire cluster's information. Now there is a chance, there vulnerability that it also may fail, but if it gets failed also, we have a kind of standby here which we call it as a secondary, but again there is a chance that we may lose the 1 hour data, because hourly it will have this image being captured by the name node. That means the image of the edit logs and the FS image. So name node becomes the single point of failure. Now to avoid this, in Gen 2 the concept of high availability had been introduced. That means again you would have one active name node, and also you will have another name node again in the cluster. This is a name node, as we have seen. This is a name node, and now we are calling this node as active node or active name node, and we have another name node because 2x is more than one name node. We call this as a passive name node. We call it as a passive name node, which acts as a substitute or standby for name node. And here the point here we have to understand is, here this passive and name node would also have the communication in between, and also it has the communication between all the different data nodes. That means passive name node is a replica of active name node. Passive name node is a replica of an active name node. So what happens if anything goes down? Generally, if something goes down, let us see in 1x version, if one name node goes down, it takes a lot of time for the cluster or the administrator to get it, make it into a live state, and also again assign whatever the functions that name node would do, and again to establish a communication between the name node and the data nodes, it would take 30 to 1 hour of time. So that is the only reason, if you have the concept of high availability or a passive name node or an active name node, if any one point in time, if name node goes down, you will have again the passive substitute available for the cluster, so that all the data, there is no concept of losing even a single second's data, because if this goes down, immediately you can access whatever the operations, whatever that you have on a cluster from this passive name node. This concept is called as high availability. So high availability had taken care the problem of SPOC, single point of failure, which was there in 1x version. So high availability was taken care by using the concept of having more than one name node, what we call them as the active and the passive name nodes. Now this can also be understood with a pictorial representation. If you want to draw a picture out of, let us say you have all the you have a data node and you also have a data node here. So data node and data node. Now here, in which again we have something called as node manager, and also we have something called as node manager. Now here we have active name node. Here we have active name node, and here we call it as secondary, or we can also call it as a standby name node. Standby name node. We also have a concept of secondary name node, but it is often not configured. It's actually optional. It's optional. So here active name node would have interaction with this data node, and this standby name node would have interaction with this name node, and these two again can have the interaction, and these two can also have the interaction. That means here you'll have whatever the information that you have on an active name node, you'll have the same information being there on the standby name node. Let us say now this is my client, and I wanted to access some data. So what happens is, this is HDFS. So let me okay, yeah, it will, yeah, let me, hi, now this client will have an interaction with the active name node. So from there the cluster would be have kind of interaction with the client. Now here what happens is, now let us say we have been saying that if this gets failed, you have a standby name node available. In fact, the fact is here they would share a common storage here. Okay, we call it as a shared memory. They will share shared memory. Now here they share some shared memory. So here, right here, so these two nodes, active and the passive name nodes, share a common memory. That means whatever there is in active name node, that always be copied onto the shared memory. If this gets any problem, you'll have every data being shared from again this memory onto the standby name node. So this is how high availability can be explained. And one point I wanted to make you very understand, you only have to know the definitions, because when it comes to configuring high availability or Hadoop Federation, that is not the key job of a Hadoop developer, or not the business of a Hadoop developer. Everything would be taken care by the Hadoop administrator. So as developers, we should be knowing what is Hadoop Federation and what is high availability.